Hi everyone, very good evening and welcome back to Geeks for Geeks, guys. Please give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Then we'll start off with today's session, guys. Okay, so you can just let me know in the chat, and meanwhile, I'm starting with the document as well. So everyone is ready for the discussion of problem of the day for yesterday. Hi Pallav Sharma and hi Rishit as well. So yes, guys, let's begin with the discussion of this problem. Hi Mark. Now, what does this problem say? First of all, let me remove the code. Okay, so obviously this problem has got some prerequisites along with it, but the problem says that we have to find the longest repeating subsequence. Okay, what we need to find in this particular string is we need to find the longest repeating subsequence. So basically the problem says that we will be given a string str and we have to find the length of the longest repeating subsequence in it such that it can be found twice in the given string. So basically the two identical strings a and b can use the same ith character from the str if and only if the ith character has different indexes. Okay, so basically if the character has different indexes, let's see this example. For example, if you will see here, let's say first string we are talking about, it is like xax. Okay, and then let's say the second string we have, let's say we have b, and b is like xax also, right? So in this case the longest repeating okay, the longest repeating subsequence in both of the strings you can see is what? In this case you can see x, because if you take this x from the first string, then you cannot say take the same x at this index from the other string. So here you have to take it from this place, right? So you can see that x is same, x must be from different positions. So they want to take the x but from different positions. So if you have this string, let's say str, and it looks like this, let's write it first of all. So suppose that you have the string str and this string str looks like this. It is like a, then we have x, then we have x, then we have z, then we have x, and then we have y. Okay, if we have this particular string, so you have to tell that what is the longest repeating subsequence here. So in this case, if you will see, let's do the indexing first of all. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, so this is the string. Now can you tell me what is the longest repeating subsequence here, guys? Anybody can tell me? If you will see, right, so in this case I have to choose. Let's say if I will do what, in this particular string only I have to choose. So what I can do here is if I will make another copy of it, axx zxy, so I have to choose the characters from these strings such that they are not from the same indexes. So let's say if I'll choose this x as the first x, okay, then I can choose this particular x corresponding to it. So basically this x and this x I can say as the same, right? So in that case one of the x is same. After that what we can do is from this particular string, if I take a yellow color, and then I will say that I can take this x from here and I can take this x from here, right? So correspondingly I can say that okay, this x and this x are matching, which are from different indexes but same characters. So now this is another x. So here we can see that what is the longest common? Is there anything else common? I don't think so, because y is not common here, because you can see if I take this y and this y, so both are same but they are belonging to the same indexes. So I cannot take this y, I cannot take this y. So basically the longest common repeating subsequence is nothing but xx. Is that clear to everyone, guys? Because what I'm doing is from the like from this string, like I'm taking things from the same string only, but I'm taking this first x from this index 1, and I'm taking the second index from this index 2. Okay, so basically this is the first x that I can say as the same. Then after that I can say that this particular x is there at this yellow position, which is at index 2. It can match with this particular x which is at index 4. So that is why double x is the longest repeating subsequence in this particular string. So is this clear to everyone, guys? Till now, till this point, everyone is clear or not? Please tell me, and then we can think of moving forward also. Is this much part clear, guys? Basically from the same string, in the same string you have to tell the longest repeating subsequence in the same string. So that is why, since we have to consider the same string, guys, so that is why what we will do is we'll write the same string again, and we have to choose the characters such that the characters are same but their indexes are different. As we have bhaiya say have made two vector. Like basically you have two strings, like you have to consider the same string twice. That is the thing. Okay, now let us say that if we consider the second example right here, so let us say that the second example is like a x x and then x and then y. Okay, and we have this as a x x x and y, right? So just let me write it more properly. Yeah, so let's say this is the thing. Now what I can do is, since I'm taking it, so I can take this x, and corresponding to this x I can take this x. Okay, now from the same string I'm taking, but I'm taking from different indexes, right? So let's say this is the string a, this is the string b, so I'm taking from different indexes. So this x is the same first thing. Then after that, if you will observe, so what happens, I can take this particular x, and with respect to this x is also same, and they are at different indexes, so I can take this x also. So now in this string also, accidentally xx is the longest repeating subsequence here. Is that clear to everybody, guys, till now? इसमें डीपी यूज हो रही है. Yes, we will use dp here because for finding the longest repeating subsequence, you can see that we have to consider two strings, and both of the strings will be the same, but in these two strings we have to find the longest common subsequence, right? The longest common subsequence between two strings will be here the longest repeating subsequence. And in the longest common subsequence, what happens, there are two different strings, but since here we have the same string and we have to consider it twice, so that is why this problem is known as longest repeating subsequence. Is it clear? Can you take one more example? Yes, I can try to take one more example. Suppose I have something like YASH, okay, and then I have what? I have got Y, then S, and then let's say I have got H, okay, and again I'll write the same string. So I have YASH, and then I've got Y, and then S, and then H. Okay, so I have to consider these two strings only. Okay, like basically I have to consider the same string only, and I have to find the common. No, AXX will not be there, because you cannot consider this X now, because you cannot consider the A here because it is at the same index now. So you don't want to consider the character at the same index. Okay, because this A is at the same index and this A is at the same index. So that is why you cannot consider it. Is that clear to you, Raghuram? Okay, so now in this case, what we can see is, let's say if you will consider, so you have this Y. Okay, so take this guy. Now corresponding to this Y, you can say that we can take this particular Y. Okay, after that, obviously for A, you don't have a, next time you don't have a A after it. So you can take this H, and with respect to this H, we can take this particular S. Right, so we have YS, and with respect to this H, we have this S. Then after that, if you take this H, and then we can take this H, because these two H are same and they are at different indexes, right? So in that case, this H also I can take. So YSH is the longest repeating subsequence in both. Okay, is this clear to Rishit? Because I've taken another example. So you can see from the first string, I'm considering this Y and this H, S and this H. And from the second string, I'm considering this Y, this H, S and this H. So whatever common characters I'm considering, common subsequence I'm considering, they should be from different indexes. Okay, everyone is clear? If you are clear till this point, so please give me a +1 if everyone is clear. And just guys hit the like button, and then we will proceed further with the further part. Okay, if you are clear till this point, just let me know. Okay, everyone is clear. The like is not increasing. You can tell me if you're clear. If you're clear, then you can hit the like button, and I'll proceed further. Okay, now for finding the common part. Now, so basically, if you will see what we are doing, we are finding the if you will see, if these were two different strings, suppose in this case, suppose there is a string A and there is a string B. In these two strings, if we are finding the longest, like if we are finding the common part, so we are finding the longest common like we are finding the longest common subsequence, right? If there are two different strings, suppose that there is str1 and there's str2, and we are finding the like we are finding the common part, the longest common subsequence there. Okay, so in that case, it is known as LCS, right? But here the string A and the string B is the same, since they are same, right? Because both the strings are same, because we will be using the same string here, because we have to find the longest repeating subsequence. Okay, so since we have to find the longest repeating subsequence in the same string, so here we can say that we can use the longest common subsequence approach and in that we'll only do one modification, that we'll use string as the same. Okay, both the strings will be the same, and if the characters are same and they belong to the same index, then we'll not consider them. So if the characters are same and they belong to different indexes, only then we'll increase the length. So is this part clear to everyone? Optimal solution is this one only. Is this clear to everybody, guys? Mark and everyone till now? Okay, just a second. So here you have to use the longest common subsequence approach only. Hi Naikach. So yeah, you have to use the longest common subsequence approach only. But since you have to find the in the same string, you have to find the longest repeating subsequence. So that is why since you are using the LCS approach, where in LCS approach you have two different strings, but since you are having same string, so that is why it is known as LRS, longest repeating. Okay, is that clear? All right. Now, what will we do here? Basically, if you will observe now, why DP will come into play? Because in this case now, if we have to find longest common subsequence or longest repeating subsequence, so the thing is that if the character is same, if suppose that ith character is equal, like in the in the first string, suppose what happens, ith character is same as the jth character in the second string, and it happens that I is not equal to j, so the characters are not belonging to the same indexes. In that case, what we can say is that we can say that okay, we will increase the length by one because one character is same, and then we will call the function. So then we can call the recursion for I plus 1th, j plus 1th, and we can pass the rest of the parameters here. But this can only happen if they are same. Suppose if they are not same, so else if they are not same, then what we can do? If they are not same, then either I can increase, right? So suppose that if the ith character and the jth character are not the same, so in that case, suppose I am at a, okay, x b y, and I have what, a x b, and let's say I have x only, right? So let's say I have x here and I have x here as well. So suppose that my ith character was standing here and my jth was standing here, right? So since they are same, but j is also same, so we can either increase our j or I. So let's say if I'll increase my j, okay, then again I'll increase my j. So you can see that this and this will be the same, right? So basically, I think both are different. No, the logic is used as same. The logic of LCS is used here also. Only a little bit of difference is there. That in LCS you only check if ith and jth are same. You don't check if the indexes are different. Like you have to check here that the indexes are different because a and b are same strings. Now that is why they, like, the logic of the LCS is used in this problem. Shivam Dubey, the logic of the LCS is used in this particular problem. Otherwise, what is the choice? You have a choice that either you can do what? Either you can increase the I, keep the J as the same if they are not the same. So you can increase the I, keep the J as the same. Or what you can do is you can have the I as the same and you can increase the J. So these are the two options. These are the choice one and this is the choice two that you have. And in these two choices, what you will choose is you will choose the maximum out of the two. Okay, and why we are using recursive approach here? Because we'll try to do what we'll try to find it out using all possible ways, right? We'll try to find the longest repeating subsequence in this case with the help of LCS concept by using all possible ways. When we use all possible ways, then recursion comes to our mind, guys. Okay, that is why. In conclusion, the logic of LCS is used are same, but yeah, only the string in LCS the string is different, but here the string is the same. Since the string is the same, so that is why we have to put this condition that if the characters are same, so the indexes should not be the same. Okay, Arman, is that clear? In LCS, you just check if the ith and jth are same, but here you have to check that if the indexes are not the same. That is the only difference here. Okay. So why we are using recursion? Because you have to try out all possible ways here. So what we will do first of all is, first of all, I'll, let's say, return a recursive function in which I'll pass the string 1 and string 2 as the same. And let us say what I will pass is, after this I can pass initial index. So I can pass initial indexes as 0, 0. And then let's say as of now I don't need to pass anything. If we'll require, then we'll see. So we can call the recursion and we can say that string, let's say we'll have the first string as ampersand a, and let's say we'll have the second string also. So we can declare like string ampersand b, and then after this we can have the int I comma the int j here. Okay, now after this part is done, so what is the condition that we should terminate, guys? Okay, if either of the two strings get exhausted, okay, please hit the like button if you're clear. What will be the termination condition? So if you remember LCS also, so the termination condition was that if I is pointing to the first string, okay, obviously both the strings are same. So suppose you have a x x and y, and then you have what, a x x y also here. Now suppose that I is pointing here. Suppose by moving sometimes, after moving sometimes, I exhaust, okay, and j is still standing here. So can I check ith and jth character now? No, because I exhaust. So if I reaches the end of the string, or if j reaches the end. So suppose that if you have something like a x x x and y, and after that what you have is a x x y, and let's say you are having what, you are having, let's say, something like j here, okay, and you are having what, you are having sorry, let's say you are having I at this place, and you are having j here. So if the j gets exhausted or the I gets exhausted, any of them get exhausted, then we can no longer have any same part, so we'll return 0 in that case. Is this clear, guys? Yes or no? That if it happens that I is equal to a dot size, right, if we exhaust the first string, okay, or we exhaust the second string, in that case what we will say is, in that case we can simply return 0, because nothing will be common any longer, because uh, either I, or if I or j, any one of them becomes uh, passes the size, right, passes the size, so then it is no longer valid, and we cannot explore it further. After this what we will do is, suppose that if it happens, right, if it happens that the ith character of the string a is the same as the jth character of the second string, okay, and it happens that I is not equal to j, because ultimately we know that these are same strings. So if they are same and they are not belonging to the same index, then we will what, return what, will return 1 plus, we'll call the recursion here, and we'll pass the string str, sorry, we'll pass the string as ab, because these two strings are AB, and then what we will do is we'll pass the index I plus 1, j plus 1, because both of them can increase by 1 here, okay. Otherwise, if they are not same, then I have a choice. Either I can increase my I and keep the j as the same. So I have the choice one here, that what I can do is I can call the recursion where I can increase the I value, and I can keep the j as the same, and okay, just a second, let me pass the strings also. So I can pass the strings a and b, and what we will do is we'll keep the I increased and j as the same. Otherwise, the choice 2 is that what we can do is we can call the recursion, we can pass a here, we can pass b here, and we can keep the I as the same and increase the j value by 1. So j index can increase by 1. This is the other choice. And since we are I did order of n square, yes, I am also doing order of n square only. This will also take order of n square for all possible ways na mark. My approach is also going to take order of n square only, okay. So in this case what you will do is you will return the maximum of the two choices, whichever choice returns you the maximum length that you are going to take at this instance. So let us just do one thing, let's try and run it on the smaller samples. Obviously I have not applied dp here right now, but I'll apply it later on so that I can show. Okay, so is equal to b dot size. B was not declared. Okay, I should declare capital B here. Just a second. But extra space, I think. Yeah, so it is working fine on the samples. When I'll submit it, so what error will I get, guys? Please tell me. I'll get a TLE error. If I get a TLE error, then my code is correct. So you can clearly see here that what we are getting is we are getting a TLE error. Now, why are we getting this TLE error? That is the main thing. So actually what happens is, if you will see, so we are starting from where, guys? If you will observe here, if you talk about this recursive function, let's name it as f. So you have this I comma j function, right? And in this two parameters are changing. So what you are doing is either you are doing I plus 1, okay, and keeping the j as the same, or what you are doing is you are calling for I comma j plus 1, like this, okay. So what will happen, a lot of calculations will be repetitive in nature. Why they will be repetitive in nature, that we need to see here. Okay, so you can see that this is the relationship, because if we are at f of ij, so what can happen here? If you are at f of ij, so either you are increasing your I, keeping the j as the same, or you're keeping I as the same and increasing j. So suppose if you start from 0 comma 0 here, so what will happen is you can call for f of 1 comma 0, or you can call for f of 0 comma 1, okay. Then here what you can do is you can call for f of 2 comma 0, okay, or you can call for f of 1 comma 1. Here also what can happen is f of 1 comma 1 you can call for, or you will call for f of 0 comma 2. So one time increasing the I, another time increasing the j. Then here also you can call for f of 3 comma 0. Here what you can do is f of 2 comma 1 you can call for. Now here you can call for f of 2 comma 1, and here you can call for f of 1 comma 2. Here you can call for f of 2 comma 1. Here you can call for f of 1 comma 2. Here you can call for what, f of 1 comma 2. Here you can call for f of 0 comma 3. Now if you will see guys, if a particular state, if you will see, if a particular thing is already calculated, would you like to calculate it again and again? Because suppose that if this value, if this particular ij is already calculated, right, if this f of 1 1 is already calculated, so would you like to calculate it again by going so much down, or you would want to directly return the repeating sub problems, you can say overlapping sub problems. This is nothing but overlapping sub problems. Now overlapping sub problems, so basically sub problems. So whenever it happens that the same like if something is already calculated and we have to calculate it again and again, so this does not make sense for us, right? Similarly you can see here, if f of 2 1 is already calculated here, so you will not want to calculate it here again, right? Because if you go down and calculate it, so would you like to calculate it again? Would you like to calculate it here again, here again? No, we only want to calculate it one time and use it any number of times. Are you getting? Because right now what is happening, you have how many, if you talk about I and if you talk about j, so total if they will be moving now, so total number of combinations will be what, I can move n indexes, j can also move n indexes. So the different number of what are the total different number of distinct calls that you can see, it will be n cross n. Okay, so here you can see that this will be n cross n, and every time it is going exponential. You can see that 1 call, 2 call, 4 call, 8 call, so it is increasing in the exponential manner. So right now the number of calls or the time complexity is nothing but order of 2 to the power n square. Okay, which is very very high. Is that clear? Right now, since we are going exponential, because every time at every level you can see that the number of calls are increasing in the powers of 2. So that is why the time complexity is nothing but 2 to the power n square. Why n square? Because if you are talking about how many different I comma j pairs we have, so we have n different values of I and n different values of j. So the total number of different pairs that we can make is n square, right? So the total number of different pairs is n square, and we are calling them again and again. So that is why they are exponential. So that is why the time complexity right now is 2 to the power n square. Is that clear to everyone till now? Why the time complexity without using the memoization, without just by using recursion? Right now we are calling the same function again and again, because if you have calculated f of 1 1 already, then why do you want to go down and calculate it again? We don't want to do this, right? So that is why what we can directly say is, if we have calculated a particular value already, so we don't want to calculate it again and again. So in this case, distinct number of pairs are what, n square. Ij distinct pairs are n square. Since we are calling them again and again exponentially, you can see the number of calls are increasing, so it will be 2 to the power n square. Is that clear to everyone, guys? Yeah, so n square different states you are having, and you have a exponentially your recursion is growing, so this will be 2 to the power n square. Yes, Rishit. Because n square are the different number of different, how many different I comma j pair you will have. The different I comma j pair that you will have is n square, right? Because I can go to n different values and j can also have n different values. So the total number of distinct pair, if there are n ways to do something and n ways to do another thing, and you have to pick one of them from here, one of them from here, so that will be n cross n, n square. It's very high, barely passes for n is equal to 8. Yes, correct. So that is why, since it is order of 2 to the power n square, so we will do what, we want to calculate each thing exactly once. So that is why we can say that we can use what, we can use dp of ij here. Okay, we can use a 2d dp here, and what we can do with this with the help of this dp is, initially we can mark all the values as -1 initially, and if it is calculated already, then we will not calculate it again, but initially we can mark the values as -1. So let's say you will come at f of 1 comma 1. Initially it will not be calculated, so it will be -1. So you'll go down and calculate it, but before returning you will store dp of 1 1, so that next time you don't have to calculate it again. So that is why every value of every different pair of I comma j, okay, will be calculated exactly once now. Okay, because when you use dp of ij, so if something is already calculated, then you will not calculate it again. So every unique pair of ij will be calculated exactly once. Okay, exactly once. And how many distinct pair you have? You have like n different values of I and n different values of j. So that is why now the time complexity will reduce to n square, because only distinct I comma j pairs you are calculating. Every pair I comma j is calculated exactly once, and there are n square pairs, right? So that is why, since every pair is calculated exactly once, so instead of exponential complexity, now the complexity will break down to n square instead of 2 to the power n square. Is that clear to everyone, guys? Till this point, please let me know if you are clear, and please hit the like button if you're clear with this, right? If you're clear why it was exponential. Okay, because see, if I will ask you guys, okay, let's say there is 1 2 3, okay, if suppose that you have pqr here, okay, if you have p, then you have q, then you have r, and suppose you have a and you have b here, and you have to choose one of the things from this place and one of the things from this place, then how many different pairs can you make? If you will see, you can make p comma a, okay, then you can take p comma b also, then you can do what, you can take q comma a, then you can take q comma b, then what you can do is you can take r comma a, then you can do r comma b. So how many different pairs you are having? Total 6 pairs you are having now. So if there are 3 choices here, okay, so here how many out of, if you can see here, you have 3 choices here, and how many choices you have here? You have 2 choices here, and out of these 3 choices you have to pick one, and out of these 2 choices you have to pick one. So total number of pairs, that different pairs possible are 3 into 2, that is total 6 pairs, right? So if it was m cross n, so it would have been n cross m, right? But here, since both of the strings are same, so in this case, how many ij pairs can you make? If you talk about the ij pairs here, so I can have maximum how many different values? N different values, and j can also have how many different values? N different values. So the total number of distinct pair that can be made is n into n. So that is why n square different pairs will be there. And if you are calling them again and again, okay, without storing them, so then it will be order of n squared, 2 to the power n square, right? Because why it will be 2 to the power n square exponential? Because you are calling states again and again, and the recursive calls are increasing. You can see every time the number of calls are increasing exponentially, right, in the power of 2. First time there is 1 call, then 2 call, then 4 call, then 8 call, like this. Okay, but if you calculate each state exactly once and store it so that you don't have to calculate it again and again, then the time complexity reduces to the number of distinct pairs that you have to calculate. That will be nothing but order of n square itself. Now, are you clear with this? I hope that this derivation thing is clear to everyone. Okay, so that is why what we require is, we require a dp here. So what I can do is I can declare a 2D dp. So let me declare a vector of vector, let's say int, and let's name this as dp, and let's say that we have n comma what, n comma vector int, and then we'll have n comma -1. So initially we are initializing this as -1. Let me pass this as a parameter here. Okay, and let me pass this as a parameter here also. So I have declared this 2D dp, which I'm passing in the parameters, and here as well I'll pass it. So I'll say vector of vector int. Just give me a second, guys. And then ampersand dp. So I'm passing it with ampersand sign. So basically I've passed the 2D dp here, and initially I've marked it as -1. And what I will do is, if it happens that the dp of ij, let me just zoom in a bit more so that everyone is clear with this. Okay, so what I've done here is, guys, I have initially declared a 2D dp, that is n cross n size dp, initially marking all the values as -1, and then I am checking if the dp of ij is not equal to -1. So this means that if it is already calculated, then you don't want to calculate it again. Then you directly want to return the result, because you don't want to calculate. If something is already calculated, then why calculate it again and again, right? So in that case, you directly return the value. Otherwise, if it is not calculated, then what you do is you calculate its value. Okay, what you do is you calculate its value. Okay, calculate its value, store it. Okay, store that particular value, so that next time you come, you don't have to calculate it again, and then return that particular value. Okay, so you store it so that next time when you'll come at this particular ij pair, specific pair, then you don't have to calculate it again. Similarly here also, if you are calculating the maximum of the two, so calculate it and store it at dp of ij, so that next time you come, so it will no longer be -1, and you can directly return the value. Okay, so if it is not calculated, calculate it, store it, and then return it, so that next time you don't have to calculate it again. Is that clear to everybody, guys? Now let's try and compile this code and see if it is working on the samples or not. I hope it should work. Okay, n was not declared. Okay, so I should take int n is equal to s dot size. Okay, str dot size. So basically, I have not declared n. That is why it gave me an error. Is it clear till now, guys? Everyone? Okay, so it's working fine on the samples. Now let's try and submit this code and see if it will get accepted or not. I hope it will. And you can clearly see that the problem gets accepted, right? So is this problem clear to everybody, guys? Please tell me. Is this problem clear to everyone? Because you can see that now our problem gets accepted. Okay, so as I said, if you will think about the time complexity of our approach, so now since we are calculating each state exactly once, each I comma j pair exactly once, so time complexity is nothing but order of n square. If you talk about the space complexity, so it is also nothing but order of n square for the dp 2d dp that I have declared, plus another order of n square will have because of the recursive stack space also. Okay, so this is the thing. So is it clear to everyone, guys? So overall time complexity, you can say, is n square only. So is this clear to everybody? You can see that if I'll open the LCS problem, LCS, if I'll open and I'll write GFG. Okay, so let me show you the longest common subsequence problem. In fact, just give me a second. Yeah, if you'll see the longest common subsequence problem now, so here you have been given two different strings, and in these two strings you have to find the longest common subsequence. So in this case, if you will see the LCS problem, okay, so you can see in the LCS problem, what we do is we have two different string. Initially, we mark the DP states as -1. Then we start from 0, 0, and we have one of the string length as n. Another string length is m. We have the first string as s1. Another string as s2. This I'm talking about the LCS. So if you will see here in the LCS, normally if I is equal to n or j is equal to m, because both are different strings, so their lengths are different. So if we exhaust any of the strings, so we return 0. Otherwise, if it is already calculated, we return it. Otherwise, if s of I is equal to s of j, okay, then what we do is if they are same, then we directly say that 1 plus recursion. But here, even if they are same, now you can see here, even if the characters are same, so we have to check with if, because the string a and b, they are same string now, because we are finding the longest repeating subsequence. So that is why even if the characters are same, right, but we need to check if the indexes are different or not, because the indexes should be different. If the characters are same, then we need to check the indexes should be different, then only we can do 1 plus recursion. Is that clear to everyone, guys? Let's explain English and everybody. This is the difference. Otherwise, in the else choice, we have a choice of doing I plus 1 j as the same, or I comma j plus 1. These things are same. You can see here in the choice 1, this thing is the same, and choice 2 is I comma j plus 1. So choice 1 is I plus 1 comma j, choice 2 is I comma j plus 1. So rest of the things are same. Only one extra condition is there, because in LCS, in the normal LCS problem, what happens, you have to check for two different strings. Okay, so in that case, if you have to check for two different strings, then you don't need to check whether I and j are different indexes or not. They can be same indexes, because they belong to two different strings. But since in the longest repeating subsequence, we are considering the same string, guys. Okay, a and b are the same strings, because we are considering the same string here. In the same string, we have to find the longest repeating subsequence. So that is why we don't want to consider the characters which are lying at the same indexes. So that is why we put this additional condition, that if in the string we are having the ith and the jth character as the same, then they should belong to different indexes. Only then we can increase the answer value by 1. So is this also clear to everybody, guys? Please tell me. Okay, so basically the bonus problem is that you can try to do the LCS problem. Okay, in fact, I'll give this LCS problem in the chat also. Just give me a second. So you can just have a look, try this LCS problem out. The only thing that you have to do is you have to not check if I is not equal to j, because this is LCS. But in LRS, that is the problem that we did, longest repeating subsequence, you have to check if I and j are not same, because a and b, both the strings are same strings. That is why. Is it clear to everyone, guys, till now? Then I will just copy this code and I'll help you out with the solution. Okay, so let me open the GFG ID, and all these questions are repetitively asked. So this is nothing but the LCS family questions only. Okay, even longest palindromic is also same thing. Okay, yeah, I'm giving this. So yeah, even like if you will see now, so these questions belong to the DP category. Okay, these questions are dynamic programming category, and this is nothing but the LCS family questions. Okay, LCS family. So firstly, as a bonus question, as I said, we have done LRS today, right? The problem that we have done is LRS. Now go back home, and as a bonus problem, what you can do is try to implement the LCS problem and try to implement the LPS also, longest palindromic subsequence also. Okay. Now if I'll open the longest palindromic subsequence now. So longest palindromic subsequence. If I'll open subsequence. Okay. So here you can see longest palindromic subsequence you are having. So here also this problem you can see has been asked in Amazon, Google, and this problem is in this you just have a one string and you have to tell in this string what is the longest palindromic subsequence. So you have to check, you have to use the LCS concept here only. But what you have to do is you have to consider the string and its reverse. So you have to find the longest common subsequence in the string and its reverse. So what you have to pass is you have to pass the original string and you have to pass S2 as the reverse of the original string. Okay, guys, is this clear? So try this problem out also. In the LPS, you have to longest palindromic subsequence problem. What you have to do is you have to check for this thing. So I'm saying is LPS. Okay, try this as the bonus problem as well. It's nothing but finding LCS of string and its reverse. Yes, Arman. Correct. So this category of problems is actually quite common. Even the shortest common subsequence and problems like that. So these problems are very common. But I hope that you got my point. And in fact, if you will see, even this LRS problem, that is longest repeating, it has been asked in few companies. You can see Amazon and Google have asked this. If you see LCS, so LCS also Microsoft has asked it, Amazon has asked it, Paytm has asked this. For longest palindromic also you can see Amazon, Google. So these problems are quite a lot asked. Okay, so that is why my agenda for today was that not only I'll explain the LRS, that is longest repeating subsequence, but basically LRS, if you just know LCS, then all the LCS family problems, if you all the subsequence problems you can very easily do. Is that clear, guys? Was it helpful? If yes, till this point, then please make sure, if the bonus problem, that is LCS and LPS, was also helpful, so please guys, make sure to give me a +1 till this point if you are clear, or you can write clear, and please make sure to hit the like button if you haven't already till now. Okay, and then we will meet tomorrow with another problem of the day. But before that, before we end, please write clear in the chat if you are completely clear with the topics that we discuss, and we discuss the time complexity as well. Why it is 2 to the power n square, first of all, because it's exponentially you're calling all of the calls. Then after that, what you do is you memorize it. So you call one pair exactly, you calculate each I comma j distinct pair exactly once. So that is why the complexity becomes order of you can say n square instead, because you calculate each pair exactly once. And these problems, you can try out LPS, I have given it in the chat, and you can try out the LCS problem as well, and some other problems, shortest common also, and other problems are there. Try them out and let me know in the comments how is your view about them. Till then, that is it for today's lecture, guys. I hope that you enjoyed this particular lecture. Thanks a lot for joining. I'll see you with another problem of the day tomorrow. Till then, good night and keep coding, guys. Thanks a lot for joining.